I got, I don't know if it was, I think it was from Mike Hines is where I got the demo. I have written in pen on the top, I hate you, and it's circled, because I like, for the demo, not like myself. But I'm kind of a qualitative chemist, and any demo that really needs, like, it needs to be 2 milliliters and not 2.5 doesn't work out well for me. And so that one I always get, I get some messed up colors. I have a better version of it. I've gotten many different versions, but I always get a little bit messed up colors with it. But I'm still going to show that demo a little bit later on. But this one uses ammonium metavanadate. Vanadate. Is that it?
No,
Yeah. I'll ask the doctor. Doctor, yes?
Metavanadate, yes.
Okay, good. And so that's available from Flynn. It's like $40 for 100 grams, which sounds like a lot, but this demo that I did, 4 setups used like 6 grams. So you got it for a long time then, for this. And so the big thing is that when I went to do this morning, I didn't have a molarity to the solution, which was a real pain for me. And so I found it somewhere, and this worked. So it's a 0.1 molar solution of the ammonium metavanadate, thank you, in a 1 molar sulfuric acid solution. Do you have a funnel? I'm sorry. Just a, so it's 240 milliliters of that, or 230 milliliters, I think it is. It says it on the back. 140 milliliters. Sounds just about right. And 5 grams of zinc, and they do recommend that it is fresh, granular zinc, not mossy or zinc dust, to get this to work. And so I did this, I'm fine, I'm good. The jitters are gone, caffeine has worn off. So it's basically looking at the different oxidation states of vanadium. And so the reactions are on the back here. And so I'm doing this in AP right now because of acidified solutions, oxidation reduction reactions in an acidified solution. And I gave the kids today just the zinc and the vanadium oxide ion, and then had them balance the rest while I was doing this demo here. And so initially, that first one, if you turn to the back, reaction 1, that VO3 minus 1 is the yellow color that we started with. And then as soon as it gets added to the zinc, it's going to get reduced to a greenish color that is here, okay? And so then what's neat about it is that there's 3 reactions go on with this one vial, this one flask. And so now I'm going to shake this here. And by shaking it, now it is turning more blue. And so it will go from green to blue. And what's happening is that the zinc that's still at the bottom is further reducing the vanadium that was the product, the green stuff in the first reaction. It's further reducing it to the second. Now, the third reaction is still within this, so now it's a nice blue color here.
That's awesome.
It is. It's pretty cool. And so I see this, we have this picture in our textbook, and I've always seen it, and I'm like, oh, I want to buy that. And so I bought it in January of last year, and then I almost forgot about it today that I had this. Now this third one says it could take up to 7 minutes to go. And yeah. So anyways, I ended up taking a stir plate here and stirring it up.
It's getting there.
It's getting there.
It's getting darker.
It's getting darker. And so now the blue vanadium ion is becoming, way over there? Really? By the time, what? Oh.
No, that's all we got.
Okay. Is there one in the front?
No.
Okay. Can I do something? All right. So now I'm going to get here. It happened rather quickly when I did this. Correctly, at least.
It reminds me of the traffic light demo, but in the opposite way, right? With the traffic light demo, you're oxidizing it when you shake it. You're introducing the oxygen into the solution and it turns color. I think it's with methylene blue.
Yeah,
Indigo carmine.
indigo carmine, yeah.
It's a 3-color one.
Yeah,
Yeah.
okay,
So that's dextrose, indigo carmine, and
Right.
potassium hydroxide there.
right.
Yes.
Right.
I was having issues with this. This is testy. I'm just gonna shake it. Okay, and spray it. All right, so the neat thing is then it goes purple, which we'll see here. And then you can make it go backwards by adding hydrogen peroxide to it. Hi, how's it going?
7 minutes.
7 minutes later, time-lapse photography.
Where's the high-speed camera now?
The stir plate is just, it's hitting the zinc on the bottom. Oh, now it's okay.
there it goes.
Now it's okay. And so, and like I said, while I was stirring this, I was going over the balanced redox reaction, so I wasn't sitting there too long. Yeah, it keeps hitting the zinc and it doesn't like it. And so then,
Oh, yeah, all the stir keeps.
yeah, it hits the zinc at the bottom,
Can you
yeah.
put it on a vortex mixer and have it spin faster?
I don't have a vortex
No, that
mix.
wouldn't work for this
Sounds really
shape.
cool though.
It sounds really cool. Now it does produce a little bit of byproduct gas, not too much, but it does. One of them said that it produced gas when I looked it up, and sometimes you'll see it published. So then the hydrogen peroxide will bring it back, and what they say is that you can reuse this solution again. So you can cause it to go back, because you've caused it to go one way, you could go back, and you could do this forever. For this second part, they do say to pour off the liquid, to decant it, and to leave the zinc separate so it doesn't keep reacting in there. I didn't grab a beaker, and I don't feel like waiting 7 minutes. Should I let it stir for another couple of minutes? Do you want to see it turn purple?
Yeah.
If you ever want to kill time in class, you know, magnetic stir. You know, then you're up on the board, and everyone's like, oh my gosh. All right, we'll let it go and